Okay, hello everybody. So today we are going to continue talking about Chapter 5, Sections 1 and 2, and we are going to continue working on some problems. Today I'm going to show you how to undo multiplication and division. So as I stated yesterday, there is a slight difference in solving inequalities versus equations. And that slight difference comes into play when you have to multiply or divide by a negative number. So I'm going to show you an example of that here in just a second. But other than that, all the other processes of solving these inequalities are done exactly the same. So let's get started. So number 6, you can see it says 6 times r is greater than negative 42. And so if I draw my line down right here, and you can see that wasn't very straight. So let me try this again. Okay, that's a little better. And I need to get rid of this 6 that is multiplying the r. And in order to undo multiplication, you need to undo it by division. So we're going to divide both sides by 6. Now, 6 divided by 6 is 1, and that's the point. The point was to get rid of that 6 so the r was completely by itself. And then we're going to put a greater than sign, and then negative 42 divided by 6 is negative 7. And so our variables listed first, and we're good. That's all we had to do. R has to be greater than negative 7 in order to satisfy the original inequality. Now, the next one is slightly different. You're going to see why here in a second. If you look at what's happening to this variable d, it is being multiplied by negative 7. Now, in order to undo multiplication, we need to divide. So that is exactly what we're going to do. We are going to divide both sides by negative 7. But this is where the solving inequalities is slightly different than it is to just solve an equation. And that key difference is if you multiply both sides of the equation, or excuse me, the inequality, or you divide both sides of the inequality by a negative. And in this case, we are dividing both sides of this inequality by a negative. And when that happens, there's one key difference, and this is the difference. The negative 7s cancel. The 147 divided by negative 7 is negative 21. But this is the difference. The sign has to flip over, the inequality sign. So if you look right here, it is a greater than or equal to, but in our final answer, it becomes a less than or equal to. And so this is really important to understand that if you multiply or divide both sides of an inequality by a negative number, the sign flips. I should say the inequality flips over. But it's only when you multiply or divide by a negative on both sides. Nothing to do with addition or subtraction, only multiplication or division. So moving on, let's look at number 8. So you can see this one right here. This one's going to have some flipping going on in here, and you'll see why here in a second. But I'm going to draw my line, okay? And then I can see that this t right here is being multiplied by negative 5. So I'm going to divide this side by negative 5, and I'm going to divide this side by negative 5. And so when I divide negative 5 by negative 5, they cancel, and that's the point. We want this variable to be by itself. 95 divided by negative 5 is going to be negative 1, 9, right? Because 5 goes into 9 once with a remainder of 4. 5 goes into 45 9 times. So a positive divided by a negative is a negative. Now here again, we divided both sides of this equation by a negative number. Therefore, we have to flip over the sign. So the sign becomes a less than sign. So it is negative 19 is less than or equal to t. Now, I don't want you to leave your final answers with the variable coming second like that. So we need to then flip the entire expression over so the variable comes first. So the t is going to go here, the negative 19 is going to go here, and then we're going to flip it over like this, and we're going to get t is greater than or equal to negative 19, and that is our final answer. That's the way that we want to write that. Now, moving on to number 9. This one's a little tricky because you can see there's a fraction on the m. All right, now the way that we get rid of a fraction is we would normally, since it's multiplying the m, you would say, all right, let's divide. But the problem with dividing a fraction is we don't divide fractions. We multiply by their reciprocals. That's where the keep, change, flip comes into play. So in this one, we need to flip this fraction over and multiply both sides by the reciprocal. And so in doing that, what we end up with is the fraction cancels. We're left with m. And then on the right-hand side, you can see we have -3 times 5 over 1. And that 5 over 1 needs to multiply another fraction. So we need to make the -3 a fraction by putting it over 1. And then we can do top times top, bottom times bottom. And what we end up with is -15 over 1. And that's just -15. Now, you might say, we multiplied by a negative. We need to flip the sign. Nope, not exactly. In this case, this sign is going to stay the same, and its m is greater than or equal to -15. Here's why we don't flip the sign. We multiplied both sides of the equation by +5, not a -5. If you go back and look in this problem right here, we divided both of the sides by a negative. That's when you are going to flip the sign. Both the numbers that are operating both sides of the equation has to be negative in order to flip the sign, and it has to be division or multiplication. In this case, we multiplied, but we multiplied by a +5 on both sides. So that does not constitute flipping the sign. So you can see it was a greater than, it stays a greater than. Now, moving on to 10 and 11, these are similar type problems of what we just got done doing, but now you can see that this number, this 3/7, is going to be negative. And so this is going to be now where we're going to go ahead and flip the sign. So it's a -3/7. I'm going to multiply by a -7/3 on both sides. And you can see this number here is negative, this number here is negative. So because we're multiplying by a negative on both sides, the sign is going to flip. And in fact, I'm going to do that first so we don't forget. And now the 3's and the 7's go away, and we're left with an R on this side. And on the other side, we need to make the 21 into a fraction. And then we need to reduce on the diagonal before we try multiplying. And so you can see 21 and 3 are both divisible by 3. So they reduce into a 7 and then a 1. And then you can multiply across the top. So 7 times -7 is going to be -49. And on the bottom, you just have 1 times 1, which is 1. So there's no need to even write that. And so your final answer is R is greater than -49. Now, the last one we're going to do today is similar to the last one. You can see that we have this -3/5, and it is multiplying D. So we need to undo that multiplication. And normally, again, we would divide, but we don't divide fractions. We multiply by their reciprocals. So I'm going to multiply this side by -5/3, and then I'm going to multiply this side by -5/3, just like that. And so the 3's and the 5's cancel on the left-hand side. I'm left with a D. You can see I multiplied, there again, I multiplied both sides by a negative. Okay, just like we did over here, the sign flipped over. We multiplied both sides by a negative. The sign has to flip over. And then what we're going to do is we are going to, let me write that sign flipped over. Okay, now we're going to make this 6 over 1. And we can reduce on the diagonal once again. The 6 becomes a 2, the 3 becomes a 1. And so we had -10 over 1, which we don't need to put it over 1. So D is less than or equal to -10. And then that's your final answer. So there you go, guys. Hopefully that made sense. As I said, this is very similar to solving equations. There's only one additional step, and that step is when you multiply both sides or divide both sides by a negative, you do need to flip over the sign. So as always, if you have any questions, feel free to email me. Have a great day.